All right, hello everyone. Welcome to this video. In our last video, we had done an easy question on lead code, which has to do with two sums, where we found the indices of two numbers, which in an array which added up to a target. And on the same day, I'm moving to my second video, which is the second easy video. I think it's a Pallindrom number. Let's look at it. Pallindrom number given an integer if x is a Pallindrom or otherwise. So I'll give you a number. Output is true. Explanation. Reads as from left to right and from right to left. Okay, it's a number that looks the same. Whether you're reading it from left to right or from right to left, that means both sides are the same. Let's check the second example. Negative. Clearly shows that when the number is negative, it cannot be a palindrome number. And in this case, we just have two numbers. So this is the center. If I start reading from here, I'll read 0, 1. If I start reading from here, I'll read 1, 0. It's not a palindrome. Yeah. So first thing is, the number is given as an integer. The best way to be reading it is to look at it like an array. So I have to convert this integer to an array. I'm going to do it this way. I've once done that, you see, so it is not quite difficult. Y x let's say x modulo 10 it's not, or let's say y x divided by 10 is not equal to 0. That means y does see numbers to divide to this. So y does see numbers to divide to. Well, I first need a list that I'm going to add an array or a list. I think I'm going to do a list because list is easier to deal with than array. List of integers. So first thing is first. And to add the last number to the list. So to the list, I'm going to add x modulo 10. So if anybody does not know what x mod 10 is, x mod 10 is going to give the remainder when this number is divided by 10. First of all, I want to say if x is less than 0, return false. There's no need to continue if it's a negative number, so it terminates at that point. Now, let's continue. So x modulo 10 just gives this last number, which is 1. So in the first case, I'm adding 1. Then now, I'm going to do x is equals to plus equals to, or let me do x equals to x divided by, that's integer division. So what that is going to do is going to knock off this one and leave me with 1 and 2. So in the first case, I'm going to have 12. The second case, I'm going to do 12 modulo 10, which will give me 2. 2 will be added to a list, knocks it off. In the third case, x divided by 10. X modulo 10. So, because in the last case, why I did that is because in the last case, x divided by 10 will be 0. Because the last case will be 1. 1 divided by 10 gives 0, remainder 1. So this is going to be an OR. So while they see a number to divide here, or if we're in the last number, this will not be 0. In the last number, we'll have 1, this will be 0, but this will not be 0. So in any of this case, it's only when we have no more numbers that this will fail. Keep doing this. So it will do this, and add to the list. Then I'll have now a list of elements. What I'm going to do is I'm going to use a for loop to go through that list. Int I is equals to 0. What I want to do is I want to move it from the front and the back of the list. So I'll use I to move from the front, and I'll use J to move from the back. List point count. Give the length of the list, but I need -1 to give the last index. Now, I don't want I to cross over J. That means while J is reducing and I is increasing, at the point when they are close or they are on the same point, because here they'll both move to 2. Here they'll be the same, or here they'll be close. I don't want J to come down and I should go up. That means the condition for stopping is, or the condition for continuation is I is less than or equals to J. That means I can never be greater than J. I plus and J minus. Okay, keep doing this. So if at some point list, I hope I can check a list like this, list I is not equals to list J, return false. Like quit the function, just return false. Else it continues going until this condition is met, or this condition is no longer satisfied. Then it will stop. If they overlap, that means it has already gone through and seen that okay, everything is fine. I think I'm going to stop here. So at this point I'll return, that means it's all no problem, so I'll return true. But if it sees a problem, I'll return false. Let me run this and check for errors first, then I check for the problem. Well, they ran perfectly, so I'm going to submit it. That was easy. That was quite easy. It's in the easy section. Going to submit it. Boom, everything went well. Memory very high, probably because it's in the list, but it beats for time. Complexity goes fast. It beats only I think I'm in the low percentile. Let me submit again to see whether this will change. How can I be that low? Like, this is the most efficient code. Still 27%. Okay. Thank you everyone for coming to this video. This is our second video, and this is what we're going to end. Make sure to check out our Twitter and my Twitter and my YouTube. The videos will be on it. And my LinkedIn. I don't have Instagram, or I'll put it on it. I'll probably put it on my TikTok. All of the accounts are in my bio. Thank you. Please make sure to follow me, because this is going to be a very interesting thing. Thank you and goodbye.